All right, so now we're going to be moving on to ramps. So number 12 has a 7 kilogram box on a ramp. The forces that we have acting on this, the normal force goes up and to the angle to the right. Gravity parallel goes down and to the right. Gravity perpendicular is down and to the left. And the force of friction is up and to the left. Ramp problems are actually much easier than many of the other ones we've been doing because we don't have a whole lot of sine and cosine right triangle stuff to do. Because what we've done is we change our y-axis to be along where the normal force is, and our x-axis then is along the hill. And gravity, we know the gravity actually pulls straight down, but we can figure out the parts of gravity, how much of gravity pulls down the hill and how much of gravity pulls into the hill, allowing our feet or whatever to still be on the hill. In this particular question, we're trying to find the normal force, and we are trying to find friction. So if we take a look at our left and right stuff, we have our arrows. Normal is up. Friction is to the left. We know it is to the left because if this was on wheels, it would roll down the hill, so friction is stopping it. And then we have our two parts of gravity. Gravity parallel is the part of gravity that pulls down the hill, and gravity perpendicular is the part that pulls into the hill. We have equations for both of those. They're on your equation sheet, and they're on the board in class. But here's where our equation starts. We have gravity parallel because that goes to the right, so that's positive, minus friction because that goes to the left. We're out of left and right arrows, so we say equals 0, meaning my right stuff equals my left stuff. My equation for gravity parallel is the sine of the angle, and that's the angle of the hill right there, times the mass of the box, times g, which is 9.8 because we're on the planet Earth, and that's going to equal friction. So now I can plug in my numbers, sine of 20, times the mass, which is 7, times 9.8 meters per second squared, gives us 23.5 newtons for friction. So now up and down, my up arrow, normal, minus my down arrow, force of gravity perpendicular. That's where my equation comes from. So my up stuff equals my down stuff. And we have an equation for gravity perpendicular, which is the cosine of 20 degrees times mg. We plug in our numbers. M is still the mass of the box, which is 7. G is still 9.8 meters per second squared. Plug into our calculator, and we get 64.5 newtons. If you do not get those answers of 23.5 newtons and 64.5 newtons, check your calculator. You're probably in radian mode. Moving to number 13. Now we've got a box, 5 kilogram box. It's being pushed up the hill with a force of 35 newtons. We finished drawing all of our forces. Normal force goes up. Gravity perpendicular goes down. Gravity parallel goes down the hill to the right, and so does friction. We have two arrows going to the right this time, and that's okay. And in this particular problem, we're trying to find the normal force and the force of friction. So I go to my left and right stuff. Friction is to the right. Gravity parallel is to the right. And the force of push is to the left. All those forces put together, right stuff are positive, left stuff is negative. It's going to equal 0. Solving for force of friction, I add force of push or pull to the right, subtract force of gravity parallel to the other side, leaving me with force of friction equals force of push minus gravity parallel, which we know is the sine of 25 degrees mg. Plugging in 35 newtons for the force of push, plugging in 5 kilograms for the mass, and 9.8 meters per second for the g, I get friction must be 14.3 newtons. Up and down, normal force goes up. Force of gravity perpendicular goes down. That's why it's normal minus gravity perpendicular equals 0. So my normal equals gravity perpendicular. My equation for gravity perpendicular is still cosine 25 times mg. Plug in 5 for mass. Plug in 9.8 meters per second squared for g. And I get that the normal is 44.4 newtons. Number 14. In this problem, we've got a 10 kilogram block. We've got the normal force going up. Gravity perpendicular going down. Gravity parallel goes to the right. Force of friction also goes to the right, and it's a 35-degree angle. The problem tells us that friction is 20 newtons. We're trying to find the force of push right there. In this particular problem, I don't care about the normal force, so I'm not even going to do the up and down because I don't have to. Adding up my left and right stuff, gravity parallel is positive, and so is friction because they're both to the right. And my force of push is minus because it's going to the left. I'm out of left to right arrows, so that equals 0. I move force of push to the other side of my equation, so my right stuff equals my left stuff. Now I can start plugging in my equations, force of friction and force of gravity parallel. Friction I know is 20 newtons. Gravity parallel is the sine of the angle, times the mass, which is 10 kilograms, times g, which is 9.8 meters per second squared. Plug all that into my calculator, and I get 76.2 newtons for the force of push.